Before we jump into the math, I want to come back one more time to talk about what it means when we talk about displacement. Displacement is going to be the function of two variables, and we can use capital D to represent this. So again, this is a multidimensional function in that we have a function of position and time. So displacement is a very general word. We can use it to think about on a string the difference from equilibrium. So again, we think about our string being at equilibrium, and then maybe we have some sort of pulse that comes up. So displacement would be this difference here between the pulse and where that string was at equilibrium. Water is very similar, that if you imagine just a perfectly flat surface of water, we know that water waves, actually kind of make it go up and down. So displacement would again be that up and down aspect. When we think about sound, this is now a longitudinal wave. So displacement has to be that shift back and forth, again, in the direction. So this is more what these waves actually look like because these are transverse, but then sound is an example of a longitudinal wave. It's the one we'll talk about most often. So in this case, displacement represents that shift, as we've already talked about. Electromagnetic waves have a slightly different situation. And in this case, displacement is actually going to be the electromagnetic field strength. So we're going to come back to this in detail in a later chapter. In this chapter, we'll introduce the idea that light is a wave, and we'll talk about it as a wave, having a frequency, having a wavelength, having a velocity, but we're not really going to talk about what it means to represent it as a wave. So we can do a lot with light as a wave without really saying, well, a wave of what? And what's going to be cool about this is we're actually going to be drawing it as an electric field, E, and then a magnetic field, B. Now, you can't tell what I'm doing. This looks terrible, but this is me trying to draw it in 3 dimensions. So we actually are going to have a 90-degree angle between the direction that our electric field is propagating and our magnetic field is propagating. So electromagnetic waves include both electric fields and magnetic fields, and the book can give you some much better 3-dimensional pictures than I do. But so when we talk about displacement, that's actually going to be the field strength. So this up and down is actually pointing to the left, pointing to the right in different magnitudes. So we're not going to worry about this now, but realize that the reason we're stopping to talk about waves is that we want to jump into electromagnetic waves, but we have to understand the basics of what a wave is first.